Hi everyone, this is Rajitha, working as Assistant Professor of Artificial Intelligence and Data Science Department in SNS College of Engineering. Today we are going to see about predictive analytics. Subtopic is time series analysis. Time series analysis refers to a specialized branch of statistical and data analytics methodology that focus on understanding temporal data that is recorded sequentially over time. The uniqueness of time series data lies in its inherent dependency on the order and timing of observation. And the core concept of time series data is understanding time series data begins with recognizing for four critical components: trend, seasonality, cyclicity, and irregularity. The trend reflects the long term direction in which the data is moving. For instance, a continuous rise in sales over several years indicate an upward trend, while consistent decline implies a downward trend. And the seasonality is repeating patterns within fixed periods like daily or yearly. Cyclicality, longer term fluctuation not fixed in period, as economic cycles. Irregularity is random unpredictable variation or noise in the data. And the essential time series technique is time series decomposition is one of the foundational steps in analyzing temporal data. This techniques involve breaking down a time series into its core components, namely trend, seasonality, and residual components. Decomposition can be additive or multiplicative depending on how these components interact. In the additive model, the total observed time series is represented as the sum of its parts, data equal to trend plus seasonality plus residual. This model ideal when seasonal variation remain constant over time. On the other hand, in the multiplicative model is the components are multiplied together, data equal to trend into seasonality into residual. And the essential time series techniques is smoothing techniques are used to filter out noise or random variations in the time series, enabling analysts to focus on the main trend and seasonal movements. The most commonly used smoothing techniques include simple moving average, weighted moving average, and exponential smoothing. And the time series forecasting is ARIMA model. That is, the ARIMA model is a cornerstone of time series forecasting. It is represented as ARIMA, where P denotes the number of lag observation in the model. D indicates the degree of differencing required to make the series stationary, and Q is the size of moving average window. The strength of ARIMA lies in its flexibility to model both trend and autocorrelation in data. To use ARIMA effectively, the time series should be stationary, meaning its mean and variance remain constant over time. If not, differencing is applied to stabilize the mean. The AR component capture the relationship between current and past values. Then I component ensures stationality. And the MA component address the error terms. ARIMA is widely used for forecasting economics, business, and weather prediction. For example, a retail chain must use ARIMA to forecast sales for the next quarters based on historical performance, accounting for past spikes or dips. Tools like Python provides automated function for identifying optimal parameters through technicals like AIC and BIC scoring. So advanced model, Sarima and VAR and Propet. This is the time series forecasting advanced model. And practical applications in data sciences, finance and retail market and manufacturing and healthcare. And the consideration is effective time series analysis is not just about modeling. It begins with the data pre-processing, handling missing values, correcting outliers, and ensuring stationarity or foundational tasks. For example, missing values can be imputed using interpolation, while outliers can be capped or transferred. Model performance must be rigorously evaluated using metrics such as RMSE, MAE, and MAPE. It is also essential to split data into training and testing sets to prevent overfitting and ensuring generally. Additionally, continuous monitoring and model retraining are necessary, as patterns in time series can drift over time due to changing external factors. Many tools and libraries are available to implement time series model, including Pythons as well as AS packages. The choice of tools and models should align with business goals, data characteristic, and the computational complexity of the application. Thank you.